Hola, everybody. Picking up where we left off here. When we have radioactivity and an isotope that we're looking at, and an atom that we're looking at, one of the crazy things about radioactivity is that most of the naturally occurring radioactive isotopes are not a one-and-done situation. So if you have uranium-238, for example, which is one of the more prevalent things on the Earth that is radioactive, when it decays, it undergoes alpha decay to start off with, which then becomes thorium-234. And this pathway that's shown here is not exact every single time, but this is one of the more prevalent pathways that these things can undergo decay. Then undergoes two beta decays to turn back into uranium, but now uranium-234. It can then undergo 5 alpha decays, and then can undergo 1 or 2 beta decays, another alpha decay, possibly another couple beta decays, another alpha decay, and then another beta decay until finally it turns into lead-206. So we have, from a single atom here, before it becomes stable, because that's why we have this endpoint here, is lead-206 is a stable isotope, a single atom can undergo 1, 2, 3, 4, 5, 6, 7, 8 alpha decays, and 1, 2, 3, 4, 5, 6, 7 beta decays, possibly. It might have one fewer beta decay than that, but no less than 6 beta decays from just a single atom. And the reason for that is, again, because when an unstable isotope decays, it does not necessarily mean it's decaying into a stable isotope. It could just be something where the isotope is thinking, oh, I'm so angry, so upset, and decay. And I'm still so upset, I'm still not stable. And it doesn't really become stable with a single decay process. Yeah, there's some radioactive isotopes that do become stable with a single decay process. But like I said, most of the naturally occurring ones don't. Most of the naturally occurring ones are very large, unstable isotopes that take a while for them to become stable. And this leads to things being radioactive for a very, very long time, just because it's not a single radioactive step that you're waiting for. It's multiple steps that have to take place before that sample becomes safe to handle. So, this step here might have a half-life of 1 billion years, and, there's probably multiple steps in the middle here that have half-lives of just a few seconds, if even that. But then there's probably 1 or 2 other steps in here that also have half-lives of thousands of years, or hundreds of years, or dozens of years even. And so it's a process. It's never a single step affair for these really big isotopes. Some of the smaller ones it is, but for the really big ones, it's not a one-and-done situation. Let's think about naturally occurring sources of radioactivity. Where do you get exposed to radioactivity? And if you're thinking to yourself, I'm very careful, I don't get exposed to radioactivity, you are wrong. You are very, very wrong. Everyone is exposed to radioactivity all the time. There's small amounts of radioactive minerals in the air, in the ground, in the water, in the food you eat. In your house right now, there is a small amount of what's called radon. Some houses are worse than others, which is why the government actually suggests that you get your house tested for radon. I have not done that, but it is something that is suggested. Here in Oklahoma, radon's not too bad, but in certain parts of the country it is actually pretty bad, which we'll see a map here in just a second. But there is radioactive stuff all around you, and it is naturally occurring. And if your thought when I say that is, oh, groovy, dude, natural radiation, nice. No, natural radiation is just as bad as artificial radiation. If you get exposed to an incredible amount of natural radiation, you are just as dead as if you got exposed to an incredible amount of artificially created radiation. One is not better than the other or less deadly than the other. It's just a matter of how much did you get exposed to and what kind was it. So the average person in America gets exposed to, for the most part, it's mostly radon, which is, again, it's the radioactive isotope that actually seeps up from the ground. If we go back to here, somewhere through here, yeah, there's radon 222. And there's other radioactive series that produce radon as well. So you have uranium, which is a solid, turns into thorium, is a solid. Protactinium, I think that's Pa. I forget. But I think Pa is protactinium. It's a solid, solid, solid gas. Actually, no, I think radium is a solid too. But the radon for sure is a gas. And so you have these solids that actually turn into a gas, which is radon. And so for the entire time that this is radon, before it turns back into a solid with polonium, the polonium will not stay in the gas form. While it's in radon 222, it will start to seep up from the ground, because again, there's lots of uranium in the ground and other stuff as well that turns into radon. And so that radon leaks up through the ground, gets into your house, gets just into the air, into your lungs. It's just mostly bad if it gets into your house, because the air in your house is stagnant for the most part. You know, it's the air in your house is the air in your house. There's not wind to carry it away. And so radon is by far the most significant source for radiation for the average person. But there's lots of other ways that you get exposed to radiation as well, to radioactivity. So just rocks and soils, if you're out in your garden digging or something like that, there's radioactive materials in the dirt. There's cosmic rays coming from the sky, so if you're thinking, oh, can't garden anymore, no, you still got stuff just coming in from space. There's radioactivity coming in from space that does not get completely blocked by the atmosphere. The vast, vast, vast majority of it does. If we didn't have our atmosphere, we would be toast. But some of it does get through the atmosphere down to us, and so there's some there, about 27 millirems is what that's called. There's also just naturally occurring radioisotopes in your body. Most people don't realize this, but bananas are actually decently radioactive because of potassium. There is potassium 40, the isotope potassium 40, which is it's not like 10% of potassium on the Earth or anything like that, but it's a relatively high, for a radioactive isotope anyway, it's relatively high in terms of its concentration in things that contain potassium. And so because bananas contain a large amount of potassium, bananas are actually relatively high in radioactivity. This does not mean that it's unsafe to eat bananas. It's just kind of an interesting fact. Someone actually, this is not an official IUPAC unit, but somebody actually made a unit of radioactivity that's called a banana equivalent, just to kind of give people an idea of that. Radioactivity is really not all that scary if it's in small amounts like that, because we're around bananas all the time. But when we eat bananas and other things that have radioactive isotopes in them, those get incorporated into our bodies. We are about, I believe, 0.1% of our body is, so 0.1% of our body is potassium, I believe. You can double check me on that. So we have 0.1% of our mass is potassium, and maybe about 0.1% of that potassium is radioactive potassium. So we have, like, not kidding, millions and millions of radioactive decays in our bodies every minute. Like, it's not, I'm not exaggerating that. It is millions of, for sure, millions if not billions of radioactive decays every day happen in your body, because you have things like potassium, things like carbon-14. Those are radioactive isotopes that have been incorporated into your body, and your body's made to handle that. When you have potassium explodes, in your body somewhere, your body's like, oh, there's some damage, fix that. Like you Your body is made to deal with those things. You can deal with damaged tissues in your body. So it's not really something we need to worry about. Our bodies are used to dealing with that. If you are sick in some way, you do get more exposure to radioactive materials. Just, if you're getting X-rays or if you're getting PET scans or something like that. This is an average. If you don't get any of those things, then these would just be 0. And if you are getting those, it would actually be larger. So it's this kind of useless information in terms of, because it's just an average, because it's kind of an all or nothing thing. But if you get, going to the dentist or something like that, and you get, your dental scans, that's a tiny fraction of the radioactivity that you get exposed to every year from radon alone. So it's not something you have to be really worried about. Now, on the other hand, if you work giving X-rays, well then, yeah, you do need to worry about that, because you don't want to be standing there, when you're giving 24 X-rays a day or whatever. I really have no idea how many X-rays an X-ray tech does a day, but if you're giving a whole bunch of X-rays every single day, you're not getting one a year like the average person, well then yeah, you would need to worry about shielding yourself from that. But the average person does not get 24 X-rays a day. And there's also some radioactive material just in consumer products. So, makeup and things like that. A lot of the stuff in makeup, it's materials that were mined at one point. You go out, I really don't know exactly what materials they would be, but there's the stuff that goes into making makeup or even clothes for that matter. Like your clothes that you're wearing right now are probably cotton, or at the very least carbon-based, because even like polymers, like nylon or something like that, those are carbon-based. There's going to be a whole lot of carbon-14 in that, because it's mostly carbon. And so that is a radioactive isotope, and so you're going to be exposed to radiation from that, from those sources as well. So I'm not telling you this in order to freak you out. I'm actually telling this to the opposite. Tell you that there's no reason to be freaked out about normal amounts of radiation. By normal amounts of radiation, I mean like anything that you do where people are not like, that is not safe, don't do that. Like, that's normal stuff. Like if you're going into a uranium mine with no protective gear, well then yeah, that's not safe, don't do that. But if you're just out doing your life and you get 2, even 3, 4 X-rays in a year, it's nothing to be worried about. There's a normal amount of radiation that everyone is exposed to all the time, and believe it or not, there is actually a decent amount of research that suggests it's actually good to have small to moderately small amounts of radiation exposure. There are certain areas on Earth that naturally have higher radioactivity than others. So, like for example, there's a place in, I believe, Iran, where they have very highly, I believe, uranium-rich sand. Just naturally speaking, there's more uranium in the dirt than there is in other places, and so it has like 2 to 3 times the normal background radiation of, just like us here in Tulsa. And they actually have lower cancer rates than pretty much anywhere else in the world. Places that have higher naturally occurring radioactivity, you would think, common sense would tell you, well, they must have more cancer because there's more radiation, more damage to their DNA. But from all the studies that have been done, it actually seems to be the opposite, where they actually have less cancer. It's very difficult to do a good study on that because you can't purposefully expose someone to radiation. That's highly unethical. So it's kind of difficult to do a good study on that. But from just looking at population statistics, it does seem that people that live with not unhealthy, so there seems to be some amount. It's like if your exposure to, well, let's see here. If your exposure to radioactivity is increasing. So this is the exposure to radioactivity at some point, and so this, if this is radioactivity exposure here, the amount of cancer seems to do something like this, to where it goes down to a certain point, and then there's a certain point where your body's like, okay, too much, and it starts to go up again. Again, there aren't really good studies on this, but from what I've seen, if you're exposed to very little radioactivity, very little radiation, you actually have slightly higher cancer rates. If you get exposed to small to moderate amounts, to moderately small amounts, you actually have lower. But then there's kind of a saturation point, if you will, where your body's like, okay, I just can't handle anymore. And so you do then start to get more cancer from that point forward. And so some people actually think that it's almost like, you know, if you exercise, like your bones actually become harder, I believe, and I'm not a medical person, but you know, if you work out, you know, your muscles get stronger by actually putting a stress on the system. It becomes harder. It becomes stronger. Harder in the case of bones, you know, stronger in the case of muscles. Like the body strengthens itself when there's a stress put on it. And so some people believe that it's kind of the same thing with this radiation, where if you have this relatively small amount of stress on the system, the body actually builds up a way of combating that. And so when something comes along that is damaging, it can handle it. Whereas if it has no exposure, so essentially like have no immune system, so to speak, to radioactivity, then you actually have higher risks. But then at a certain point, you know, there is such a thing as too much exercising. We actually start to hurt your body. Same kind of thing here, where there's just a certain point where like, no, that's too much radiation. It's going to start going back up in terms of the dangers. So real quick here, this is a map of the different levels of radon in the country. So the red is bad, yellow is the least worrisome, and then the orange is in the middle. And so here in Tulsa, you know, we're relatively low, so that's actually Tulsa right there. But northeast Oklahoma, relatively low amounts of radon. It's not something that I would worry about too much. Poor Iowa. Every single county in Iowa, and North Dakota too, I guess, are both in that high amounts of radiation. So certain areas and places like Colorado, the reason why there's quite a lot here is just because the rocks in the ground are different. There's a lot of granite in the ground, and granite tends to have a disproportionate amount of uranium in it, and so you get a good bit of radon coming up from that. This is the same reason why I believe in a previous video I talked about how if you have a marble countertop in your kitchen, that marble countertop is radioactive. Again, not so much that you need to be worried about it. Don't go ripping out your countertop because I told you this. It is perfectly safe. But there is a disproportionate amount of radioactive isotopes in marble versus, you know, just going out in your backyard and getting some, you know, just a pebble, you know, off the ground. There's a disproportionate amount of radioactive isotopes in marble. That's just the way the world is. Alright, in the next video we'll talk about actually detecting radioactive decay. This one went a little bit longer than I expected. I get a little bit, I get excited talking about these things. It's, like I said in the first one here, it's one of my favorite topics, so I tend to go off the rails a little bit. But I hope you find it informative and maybe entertaining. So we'll talk about dosimeters in the next video.